Okay, 3.5 measures of spread. So measures of central tendency are values around which a set of data tends to cluster. And as a recap, measures of central tendency are mean, median, and mode. Okay, there are other measures, but those are specifically central tendency. However, to analyze a set of data, it's useful to know how spread out the data are. Measure of spread describes how the values in a set of data are distributed. Here are some of the terminologies that you'll encounter. So we already talked about range in the last lesson. So as a recap, range is the difference between the least and greatest values in a set of data. Okay, so the interpretation of this is the smaller the range, the more consistent the data. So this is an example. Okay, 3, 3, 4, 4, 5, 6, 6, 7, 8, 8. If you take a look at the highest number, which is 8, and the lowest number, which is 3, and just to point out, these numbers are given in order, the range is 5. So all of these numbers occur over the range of 5 different numbers. Now, quartiles. We already actually talked about one of the quartiles, and I'm going to get into that. So quartiles are 3 values that divide the data into 4 intervals. If you're thinking about a set of data, you only need to actually draw 3 lines in order to divide it into Q1, Q2, Q3, and Q4, just as an example. And that was a quick example. It's not accurate. I just wrote the lines so that you guys can have that visual. Okay, as I explain these. Okay, and there's going to be an equal number of data in each of these intervals. So I'm actually going to explain quartile 2 first. This is the median. We already talked about the median. That's one of our measures of central tendency. This is also known as the second quartile. This is when 50% of the data lies below that number and 50% of the data lies above that number, obviously when arranged in increasing order. Okay, and we did that for median and mode, just as a reminder. So as a reminder, this is an example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 data points here. Okay, if you remember us doing the 10 divided by 2, which is 5. So since it's an even number, 10 is an even number, we have to add the 5th and the 6th number and then average those out. So 1, 2, 3, 4, 5. So the median will be between the first 5 numbers and the second 5 numbers. And it is actually going to be the average of 5 plus 6 divided by 2, which is 11 over 2, which is 5.5. So this is going to be Q2, and this is going to be 5.5. Okay, and as you can see again, 50%, so 5 numbers lie below, 5 numbers lie above. Now, let's talk about Q1. This is quartile 1, or the first quartile, also known as lower quartile. And this is where 25% of the data points are below that number and 75% are above, right? So it's like 1/4 of the way into the numbers. So if we only look between the beginning and Q2, how many numbers do we have here? Well, we have 5 numbers. So we want the middle number. So 5 divided by 2 is 2.5. Because 5 is an odd number, we round up. We're taking the third number, which is 1, 2, 3, which is 4. So 4 is our Q2. Q1. Okay. Now, the last one, Q3, which is known as the upper quartile, third quartile. Okay. This is the value which, this is the flip. 75% of data is below, 25 is above. So if we use Q2 as our marker, there are 5 data points above Q2. So I'm going to say there's 5 data points. We divide by 2. We're basically getting the same thing as Q1. This is going to be our third number, but it's specifically above Q2. So 1, 2, 3. It's going to be 7, and that's our quartile 3. And the way we can graph this data is by creating a box and whisker plot. Okay, the graph representing the first quartile, the median, again, this is quartile 2, and the third quartile of a set of data within a box. The least and greatest data are represented by the whiskers, okay, which extend from the box. So I'm going to give you a quick example, then we're going to do actual concrete examples. We're just going to label, and this is just a rough version, okay? It's not going to be super specific, but what we're going to do is we're going to label quartile 1, quartile 2, which is the median, and quartile 3. So Q1 is 4, so this number on the axis is going to be 4, this number is going to be 5.5, and then this number is going to be, 7. I didn't put it in there. 7. Okay, that's going to be the box. So quartile 1, median, quartile 3. Now, the whiskers are going to extend to the smallest number, which is the first number, right? And that's used in our range as well. That's 3. And the upper whisker is going to extend until 8. Okay, when we do this, so this is just a rough idea, but when we do this, this number line at the bottom will actually draw our Q1, Q2, Q3, max and min right at the actual numbers that they would be associated with on that number line. Now the interquartile range is the range of, it's technically the central half of the set of data, so like the middle half. Okay, when a range least to greatest. And this is a measure of how closely the data clusters around the mean. And how we calculate this is Q3 minus Q1. So what was our Q3? It was 7 minus our Q1 was 4. So our IQR, which is the interquartile range, is 3. So around the mean, our data clusters 3 points. Now, variance and standard deviation go together. Okay, they go hand in hand. The variance is just the square of the standard deviation. This is a measure of how far the data is spread out from the average value. So what actually happens here is we take every single value individually that's listed. So say x1, x2, x3, x4, x5, all the way to xn, n being the number of data points that we have. And we subtract the average. We subtract the mean, which right here is x bar. So the first data point minus x bar, then we square it, plus the second data point minus x bar, and then we square it, plus the third data point minus x bar, then we square it. Okay, all the way till the last data point minus x bar, and then we square it. Okay, this looks super confusing. It's a very complex equation when you look at it, but when we break it down into a chart, it's not going to be that difficult. Okay, and all of these x1, x2, x3, all the way to xn are data values, and then we divide by n, which is the number of data points. Now, standard deviation is approximately the same thing, except for the standard deviation takes the variance and square roots it. So standard deviation is the square root of the variance. This measures the typical distance of a particular value from the mean. Okay, so here's the interpretation. The larger the deviation, the looser the data is clustered around the mean. So there's a bigger spread of data, and therefore the data is less consistent. Now, the smaller the deviation, the tighter the data is clustered around the mean. And we can say the same thing, the opposite. The less the spread of data, the more consistent the data is. Okay, so less is more consistent, the greater the spread, so the more spread out, the less consistent. Okay, and when we look at this is called the Riemann sum. Okay, this means sum or add up all the numbers. Add up all of the numbers. Okay, so what we're going to do is we're going to add each score minus the average squared divided by n, which is the number of values. And then once we get that, which is the variance, we're going to just square root it. Example 1, Iris works part-time selling cell phones. She recorded the number of phones she sold each month for the last 12 months. So for this set of data here, find the Q1, Q2, and Q3 of the set of data. We're going to then calculate the range in the IQR. Then we're going to display the data in a box and whisker plot. Okay, so the first thing to do is to list the data from smallest to largest. So let's go ahead and do that. So the smallest I see is 6 and then 7, and I point those out because they're just one digit each. And I'm looking for anything in the teens, 13, 17. Then I'm looking for anything in the 20s, 20, 25. Then I'm looking for anything in the 30s, I get 39. Anything in the 40s, I get 41, 43, and 49. And then I get 51 and then 62. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so n equals 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 numbers. Okay, so we can go ahead and start. So let's do Q2 first, okay? So Q1, I'm going to leave a little bit of space. Let's do Q2. So 12 divided by 2 is going to be 6. So we have to take the average of the 6th and the 7th term, okay? So 1, 2, 3, 4, 5, 6. The 6th term is 25, and the 7th term is 39, okay? And we're going to go ahead and add those together. So we get 64, and then we're going to divide by 2. So this is going to be our Q2, and our number is 32. Okay, now for Q1, we have 6 numbers below our Q2. So 6 numbers divided by 2 is going to be 3. That means because it's an even number here and we don't have a decimal there, we're going to take our 3rd and our 4th number and we're going to average them out. So 1, 2, 3. So we're going to average out 13 plus 17. So 13 plus 17 is 30, divided by 2 is 15. Okay, so our Q1 is 15. Now our Q3, it's the same approach as our Q1. Okay, so I'm not going to actually rewrite this time. I showed it in the definition. So we're trying to find the 3rd and 4th number and then average them out. But this is the 3rd and the 4th number above Q2. So 1, 2, 3, we get 43 and 49. And when we add those together, we get 92. divide by 2, and we get 46. Okay, so right here, our Q3 value is 46. Okay, so now we have Q1, Q2, Q3. We can find the range, which is going to be the highest number, 62, which is max, minus the minimal number, which is 6, which is 56. Okay, so this data is spread over 56 points of data. Okay, and now the IQR interquartile range is going to be Q3 minus Q1. So that is our 46 minus our 15, right? 46 minus 15. And if we do that in our calculators, we get 31. Okay, so our middle half of the data is over 31 numbers. Okay, and remember our central half of the data, so our inside half of the data, this doesn't take into account outliers, right? So all the outliers would be way too high or way too low, right? They would occur here and here, so no outliers. Okay, now let's go ahead and display this on a box and whisker plot. Okay, so here's our number line. We are going to do the box first. So Q1 is at 15. So on this number line, 15 is approximately right here. So floating up in the air, I'm going to draw a line, vertical line. It's going to be 15. Now Q2 is at 32, which is about right here, right? 32. And draw that vertical line. And Q3 is at 46, which is going to be just over halfway between 40 and 50. Okay, so here's our box. And now our whiskers, we're going to do the lowest number. And I mean, we have the range right here, 62 and 6. So the lowest number is going to be 6. So we're going to draw a whisker down to 6. And the highest number is 62, which is right here. So we're going to draw a whisker all the way up to 62. Okay. And this is our box and whisker plot. Example 2, Carmela's monthly gasoline expenses in dollars for the past year are recorded in this chart below. So first, let's calculate the mean of the data. Okay. So for the mean, it's going to be 64 plus 83, okay, plus 77 plus 88, plus 69 plus 71, plus 65 plus 72, plus 67 plus 74, plus 90 plus 80. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, that's 12 months. And when we put that into our calculators and we add them all up, 65, 72, 67, 74, 90, and 80. I get 900. And then we divide by 12 because it's the number of data points. And I get 75 is the mean. So the mean amount of money in dollars, so she averages about $75 a month. Now we want to complete the table below and then calculate the standard deviation. So we have X as the expense and we have a list. So what we first want to do is we want to do 64, which is our data point, minus the average, which is 75. Okay, so when we do 64 minus 75 in our calculators, we get negative 11. And you can just put this over here. We'll save some writing. And then we're going to square it, which is 121. The next one, 83 minus 75. Okay, 83 minus 75, we're going to get 8. And 8 squared is 64. Then we're going to do 77 minus 75. 77 minus 75 is 2. So 2 squared is just 4. Okay. 88 minus 75. And we're going to go down this entire column and do the same thing. So that's 13. So 13 squared is 169. Okay, so we have 69 minus 75, which is negative 6. When we square that, we get 36. We get 71 minus 75, which is negative 4. And when we square that, we get 16. 65 minus 75, which is negative 100, or sorry, negative 10. When we square it, we get 100. We get 72 minus 75, and we get negative 3 for that. When we square it, we get 9. 67 minus 75, we get negative 8. When we square that, we get 64. Okay, 74 minus 75, I get negative 1. Square that, we get 1. We're going to do 90 minus 75, which I get 15. And when we square that, we get 225. Okay, 80 minus 75, we get 5. And when we square that, we get 25. Okay, so what we want to do is we want to add up all these numbers in this column. 121 plus 64 plus 4 plus 169 plus 36 plus 16 plus 100 plus 9 plus 64 plus 1 plus 225 plus 25. And I believe we get 834. So standard deviation, once we've completed this entire chart and we get this number, this is our number that we put in for the sum of x minus x bar squareds. Okay, so what we have here is 834 divided by n. N is 12, right? Because this is talking about the data over 12 months. So when we do 834 divided by 12, we get 69.5. And we get 8.336666. Okay, so therefore the standard deviation is 8.3. It's approximately 8.3. Okay, and this would be measured in amount of money. So $8.3. Oh, so we want to do 2 decimals then, because it's measured in dollars. 8.34. Example 3. Joanna's mathematics test scores have a mean of 81%. So let's go, mean is 81%. And a standard deviation of 5% is Joanna. Okay, then we have Adam. His test score has a mean of 84% and a standard deviation of 10%. Whose test scores are more consistent, and what do these measures of central tendency and spread tell you about each student? Okay, so let's compare the standard deviations. Which one is less? Okay, so Joanna's test scores with an S, have a standard deviation of 5%, which is lower than Adam's, right? Because we want to compare. So when we compare, we have to talk about the other one, whatever we're comparing to. So it is more consistent. Okay, if you think about it, her test marks are clustered more around her mean. So her test marks are clustered Let's go closer to her mean. So taking a look at the means, so Adam's mark is higher. Adam's mark, and then like that's a mean mark, right? Average mark is higher. So that means, because the standard deviation is 10, that means he kind of like went up 10, which is like to, 94, and down 10 to like 74 type of idea. Okay? Standard deviation's like give or take. Joanna only really went up to 86 and down to maybe we can say like 74, right? So, and that's like that's just like how they're clustered. So Adam's mark, which is the mean, is higher. So Adam clearly achieved like higher marks when they were high and lower marks when they were low. Okay. So higher marks and lower marks. But at the end, they averaged out. So averaging out to an overall higher mark. If we're comparing whose mark is higher. Mark than Joanna's. So Joanna may have been like consistently getting like 74, 78, 80, 80, 82, 82, 85, or yeah. And she's consistently getting these marks clustered around the mean. Adam's marks are just more spread out. His average being 84, he could be like getting a 74, 94, 92, 78. Like they're just way more spread out. Okay, and that's the interpretation.